Hey everyone, welcome back. In this lesson, we're going to talk about a specific type of application of quadratics. It's called projectile motion, and it's related to anything where you're throwing a ball into it in the air, shooting a cannonball out of a cannon, anything that's falling through the air. So it's not going to be something that has multiple forces behind it, where you're going to have a rocket that keeps propelling it, but something that had an initial force behind it, and the object goes up and then it goes down. That's called projectile motion. And so the application of quadratics is huge in this real world scenario. Okay, so here's an example. Here's a guy being shot out of a cannon. I do not recommend this, but some people do it for fun, do it for money. That's what they do. Anyways, you notice that I put it on a XY axis here, right? I got XY axis. And so we could say, actually, you can't see the X axis there. You can't see the little X. There's the little X, okay? We can say that this guy's height is related to how far he has traveled in the horizontal direction, okay? And so let's identify some key components of his path. Now notice that his path is a parabola, right? It's a parabola. Every object that falls through space follows a parabolic path, okay? And so what are some key features of a parabola? Well, there is the vertex, the highest point or the lowest point of the parabola. There are the x-intercepts, right? And that's where the parabola crosses through the x-axis. And there is the y-intercept, and that is where the parabola or the function crosses through the y-axis, okay? So let's go ahead and identify what some of these things mean in the context of real life, okay? So if I were to ask you for the y-intercept, I'm not going to say what is the y-intercept in a real world scenario. What I'm going to ask you to do is determine a certain thing, a certain event within that real world scenario, okay? And so what would the words be that I use that makes you think y-intercept? Well, in our picture, we see this y-intercept here. Now, the cannon is a little bit deceptive here. Normally, the cannon would be behind and whatnot. But the y-intercept, we would say, is the initial height or the starting height of that object. It's whatever the object started at as a height. So if I was playing baseball and I was to throw a baseball, right? Just throw the baseball. I'm 6 feet tall. So it would be reasonable that the initial height would be 6.5 feet, right? Maybe 7 feet if I'm reaching way up here to throw it, right? So my initial height would be 7 feet. That would be the y value of my y-intercept. So my y-intercept would be 0,7 because I initially started throwing that ball at a height of 7 feet. Now, let's say that I was standing on the top of a cliff or the top of a building, and I took a rock or a coin and I threw it up into the air. Well, the initial height is, and then it goes down and it goes back down, and then it goes up and then goes back down, and it hits the ground below you. Now it hits the ground where you're standing at the top of a building. The initial height of that coin or that rock is going to be the height of that building, or the height of the building plus the height at which I threw it from, okay? So the initial height is the y-intercept, okay? What is the axis of symmetry in context? Well, the axis of symmetry is this line that cuts the parabola in half that reflects the parabola. But notice the axis of symmetry here occurs when the guy is at his highest point. So we would say the axis of symmetry is how long it takes for the object to reach its maximum height. So in this case, it took, maybe 50 feet for him to reach his maximum height. Or in some context, it took 3 seconds for him to reach his maximum height. That is the axis of symmetry. The vertex is the actual coordinate. Well, the y value of the vertex is his maximum height, the highest point that the object reaches. So that is specifically, this is the y value of the vertex, okay? So when you hear me say, what is the highest that that rock got off the ground, then you need to be thinking, I got to find the vertex, okay? If I say, how long does it take for the rock to reach its highest point, then you're thinking, I've got to find the axis of symmetry. If I say, how high did the rock get thrown from? What was the height at which it got thrown from? Then you're thinking y-intercept, okay? What are these things? Now, obviously, we have one more thing. That's the x-intercept. Now, we would say that the x-intercept is how long it takes for the object to hit the ground or hit the water or whatever that line represents. How long does it take the object to hit the ground? So in this case, maybe it took, I don't know, 120 feet. It traveled in the x direction 120 feet before it hit the ground. Or in some other context, it took 4 seconds or 5 seconds for the object to hit the ground, okay? So when you see these prompts here in black writing, you should be thinking in your mind, okay, these are the things that he's asking for, okay? So let's go ahead and write this down. And actually, let me take a step back. You should be writing this down for sure in your notes, okay? So go ahead and pause the video if you haven't done that yet. But I want you to continue writing this down, the application of quadratics. What is the process? How do we do this? Well, the first step that you could do is to draw a picture, right? Draw a picture of what's going on. The object is starting somewhere and it's going up and then it's going back down, okay? The second step is to translate the question into what you're looking for in terms of math, in terms of the parabola. And so we just went through the description of what each of those things mean in the context of math, okay? Step 3 is to solve whatever it is you're looking for. And then step 4 is to interpret your results. So for example, we drew a picture, whatever the scenario is. If the question says, what was the height that the object was initially thrown from, then we need to translate that. Well, the initial height is the y-intercept. Okay, so we're looking for the y-intercept. All right, we find the y-intercept. Go and solve it, whatever it takes to find the y-intercept. Now we interpret the results. So we write our answer in a final sentence. We say that the object started off at an initial height of 7 feet, 32 feet. There, done. And that's the process, okay? All right, let's take a look at one example of this, and it's going to be a pretty thorough example. A ball is thrown straight up with an initial velocity of 14 feet per second. Actually, that's not very strong. That's not a very strong throw, 14 feet per second necessarily. But h of t models the ball's height in feet with respect to time in seconds. So we would say, for example, once I get through all these questions here, let's let this play out. I'm going to give you a function here. So I have h of t here. This represents the ball's height in seconds, or after so many seconds. So I would say after 2 seconds, what was its height? We would plug in 2 to the t value to figure out how high it was off the ground. Or what was its height when t equals 1 second? We plug in 1 to figure out its height, okay? Now, what's interesting about this, if you've taken a physics class, you might recognize this, that every object, every projectile motion goes, every projectile goes up and then it's going to go down. It's going to follow a parabolic path. Well, what is causing it to come down, right? Why can't it just keep going up? What is the force that causes it to come back down? Well, that's obvious, right? It's gravity. Gravity is the force that causes the object to fall back to Earth. Well, in a quadratic, this initial number here, this a value, the -16, is the force of gravity on the object. That number is a constant value. That -16 is in terms of feet per second squared. Now, I'm not going to get into the details of what that all means, but this -16 represents gravity. It's negative because it's pulling the object downward, okay? So this is gravity. This 14 is the initial force that was pushing the object upward. So you can see here, it has an initial velocity of 14 feet per second. So this 14 is the, oops, drop my microphone. This 14 is the initial velocity upwards, okay? So all three of these things represent something very important, okay? And we'll talk about what the 3 means. We should know what the 3 means, and we'll talk about that in a second. But gravity, the initial force on the object, and then we'll talk about that, okay? So let's go ahead and read the question. In A, it says, what is the ball's maximum height? What is the ball's maximum height? So the maximum height. Well, before we go to solve this, it might be a good idea to draw a graph of what this looks like. So the ball was thrown in such a way, let me focus here. Okay. The ball was thrown in such a way that it goes up and then it comes straight back down. It was thrown straight up into the air. But over time, it's going to look something like this. Over time, the ball is going to go up, and then a little bit later, maybe a second later or 2 seconds later, it reaches its highest point. And then maybe 3 seconds later, 4 seconds later, 5 seconds later, it's hitting the ground. So as time passes on, the ball's height is indicated by the height of this graph, okay? So there's my parabola. And notice I started out at an initial height, it went up, and then it went back down. So let's go ahead and interpret, this is h of t. Let's interpret this meaning, the maximum height. What is the maximum height on the graph? The maximum height is whatever this value is. That is the vertex. So I know that I'm finding the vertex here, okay? How do we find the vertex? Well, before we find the vertex, we got to find the axis of symmetry. That's the first step. And remember, the axis of symmetry is x equals negative b over 2a. Well, in this case, we don't have an x, we have a t. So I'm just going to replace it. I'll just say t equals negative b over 2a. And so we would say negative, parentheses 14, over 2 times negative 16. Now, to be honest with you, this is going to get kind of gross because it's not going to be nice, clean numbers. It's going to be really decimal heavy numbers because we're talking about real life here, right? Things don't always come out perfectly, okay? So this simplifies to negative 14 over negative 16. And I'm going to use my calculator to determine this value. And so this value, negative 14 over negative 16, is 0.4375, okay? So what is this? Is my axis of symmetry? We would say that it took 0.4375 seconds to reach the maximum height. So this point, or this coordinate, this value on the t-axis is 0.4375, okay? Now from there, we're going to take that and plug it into our height function. So h of 0.4375 is equal to negative 16 times 0.4375 squared plus 14 times 0.4375 and then plus 3, okay? Then we'll use our calculator and do our order of operations. So this would be negative 16 times 0.19140625. Okay, notice I'm writing down all the digits because we're looking for a very accurate number here. We'll round at the very end, okay? And then we'll do our multiplication. So then this negative 16 times the 0.19 number is negative 3.0625. And then the 14 times the 0.4375 is 6.125. And then plus 3. And then that will all add up to 6.0625, okay? So now what is our vertex? Well, our vertex is going to be 0.4375, comma, 6.0625, okay? So that's this coordinate right here. That's our vertex, okay? So remember the process. Number 1, draw a picture. Check, did that. Number 2, translate what the question is into math language, into what it means in the parabola. Well, we translated the maximum height is the vertex, so we're finding the vertex. And step 3 was to solve, so we found the vertex. And step 4 is to interpret. So let's write a sentence about this. We would say the ball reaches a maximum height of 6.0, I'll say just round it to the nearest hundredth, 6.06 feet That would be our answer to this question, but I'm going to add to this just a little bit. Comma, 0.44 seconds after it was thrown. Okay, so we're going to want to write out a sentence for our final answer. It's not just a number anymore. We are applying it to real life, so we have to relate it to context, and we have to write a sentence about what it means. The ball reaches a maximum height of 6 feet approximately, about a half second after it was thrown. So that is A, and that is our answer. Okay. All right. For B, let's go ahead and take a look at B. B says, how long did it take for the ball? How long did it take for the ball to hit the ground? How long did it take for the ball to hit the ground? Well, first things first, we got the graph already. Okay, we got the graph. Let's go back to the graph. How long did it take for the ball to hit the ground? Well, this represents the ground here. So this is where it hit the ground. What am I asking for? I'm asking for the x-intercept, or in this case, the t-intercept. So I'll write this down. The question that it's asking is to find the x-intercept, okay, or the t-intercept in this case. Okay, so how do we do that? How do we find x-intercepts? We find x-intercepts by setting y equal to 0. Now, in this case, remember h of t equals y. So we're going to say 0 equals negative 16 t squared plus 14t plus 3. And then we solve this. Now, knowing that the answers are going to probably be really gross, because we're talking about real life scenarios, and looking at our vertex here, it was really gross. Which method is most beneficial here? Well, because we have A, B, and C, we could try factoring or the quadratic formula. But because we know we're going to get pretty gross numbers, or we can predict that we'll probably get pretty gross numbers, I think the quadratic formula would probably be best. So we'll say x equals, or in this case, t equals negative b, so negative 14, plus or minus the square root of 14 squared minus 4 times negative 16 times positive 3, all over 2 times negative 16. Okay? And then we'll simplify the 4 things there. So it's negative 14 plus or minus the square root of 196. And then negative times a positive is a positive. 4 times 16 times 3 is going to be 192. And then all over negative 32. Okay. Now from here, we're going to combine those terms inside the radical. So we have negative 14 plus or minus the square root of 388 all over negative 32. We're getting there. Now the question is, should we write our answer as a simplest radical form, or should we round our answer so we have decimal values? If we're talking about real life scenarios, we want decimal answers. We want to know exactly where it's at, or not exactly per se, but the time at which this is happening. And if I say, oh, it happens at 2 radical 3 seconds, that doesn't make any sense. But if I say it happens at 4.25 seconds, that makes more sense. So we want to put this into decimal form. So we're going to use our calculator now and figure out what the square root of 388 is. And the square root of 388 is going to be 19.698, and then over negative 32. From here, we're going to break up our answers. So remember, we would say t equals negative 14 plus 19.698 over negative 32, and negative 14 minus 19.698 over negative 32. Okay, and then we'll just combine like terms, simplify this guy, and get an answer. So we end up with 5.698 over negative 32 for this one. And then this one's going to be negative 33.698 over negative 32. And then we'll divide. So we end up with negative 0.178 for the first one and 1.053 for the second one. Okay, so here we have actually 2 x-intercepts. Let me go ahead and write them down. Remember, it would be negative 0.178 comma 0 and 1.053 comma 0. So what does that mean? Well, if we go up to the parabola, it means that we're going to go back 0.178 backwards, and we'll find our first x-intercept. And our second x-intercept is to go to the right 1.053. So let's go back up to the parabola. The way we graph it, we can only see one x-intercept or one t-intercept. But if we go back in time, we'll see the other one on this side of the t-axis, or sorry, the h of t-axis. So we know we would get another one somewhere around here, and that's what the negative answer was that we got. This is the positive answer. This is going to be 1.053 for a t-value. And then this one back here was going to be negative 0.178. But we don't care about this one because this is before we started counting time. This was before time began. So when did the object hit the ground? How long did it take for the object to hit the ground? It took this amount of time. So what did we do? We read our question. We translated our question into something that we can solve in math, okay? Then we solved it. We got an answer. Here's our answers. And now we need to interpret our answer, so we need to write a sentence. We would say it took 1.05 seconds for the ball to hit the ground. And that is our answer for B. Okay. So that's a great example of applications there. We got one more problem to look at here. So let's go ahead and take a look at that. C is actually a pretty easy one. C says, how far off the ground was the ball when it was thrown? How far off the ground was the ball when it was thrown? Well, looking back at the graph again, right? Just going to re-graph this a little bit. How far off the ground was the ball when it was thrown? Well, this line represents our ground, and this is when it was thrown. So what am I looking for there? Let's translate what the question is into math. We're looking for the y-intercept. Now, we don't have a lot of work that we have to do here. We can just look at the standard form of the parabola and recognize the value of our y-intercept, but we need to make sure we write it correctly. We're going to write it as a coordinate. It's 0, 3. So our y-intercept is 0, 3. So we've got the answer now. We translated it. We did the work. It was simple work. Now we just need to write a sentence. Our answer would be this. The ball was thrown from a height of 3 feet. That's pretty low. I mean, I guess I'd have to throw it underhand, right? If it was 3 feet, or have to be laying on my back, throwing it up in the air somehow. But that is the answer to part C, okay? So I hope that you found this idea of parabolas and quadratics relating to a real-life scenario interesting. And I hope you have a good understanding of the process of what you need to do in order to answer some of these questions. It can be difficult translating some of these things, so I hope that helped out. If you have any questions, please comment below or find me in a tutoring session somewhere, and I'd be happy to help you out. Have a great day.